The absolute value of a number, by definition, is the distance from 0 to that number. So, for example, if I look at just a number line, just looking at a number line and at 0, if I'm looking at, say, the number -3, okay, the absolute value of -3 is, by definition, the distance from -3 to 0. That distance is 3. Well, we can think of the absolute value of a complex number in the same way. If I was looking at the complex number, say 3 plus 4i, I look at the complex plane, I can plot this number, and -3 plus 4i, we've got our -3 real part, and then our 4 imaginary part. Okay, and the distance from this number to 0, that's this line right here, that's that segment. This is going to be the absolute value of that number. Well, that number, if we drop that down and we see that we get a right triangle here, this length right here we can think of as the hypotenuse of that triangle. And then that right triangle, the Pythagorean theorem holds. And so, given a complex number, a plus bi, the distance from that number to 0 will be the hypotenuse. Well, that distance squared is equal to a squared plus b squared. Right? That the Pythagorean theorem says a squared plus b squared equals c squared, where c is that length there. And that gives us then a formula for the absolute value. It is simply the square root of a squared plus b squared. This is often also called the norm of the number, z, but either way is fine, the absolute value or the norm of z.